Hello friends, welcome to another Golang tutorial. Today we talk about how to handle files and perform I/O operations in Go. The data on our computer is some kind of file, either traveling along the wire or resting on a storage device. Irrespective of where the data is, we are always dealing with a sequence of bytes. This byte-level thinking would simplify how you see files in Go and in any other programming languages out there. Before we go into the code, I'd like to demo one of the applications we are going to work on during the course of the tutorial. It's a simple but useful program that shows the power of I/O operation. The program knows how to chunk a file into smaller parts and also knows how to assemble the file back to its original state. Doesn't that sound exciting to you? I have more for you. So grab your coffee or any drink of your choice, relax and enjoy the video. Let's look at the demo. So here I have two files. This is the program file. This is the file that we are going to chunk into smaller pieces. So I'm going to call the program. I'll pass an action called split. I'm going to give it some size. You can give it any size you want. Then the name of the file, of course. Make sure we don't miss our equal sign. Now we've seen that worked. If I go ahead and list the files here, as you can see, we have all the files are now in different parts, and the original file is no longer there. Something we're also doing here, we have like a metadata that we're using to keep track of the file. We have about 41 parts. Now, how do we reconstruct the file? I'm just going to tab up. The same program, we no longer need the size because we have the size saved in the metadata. And the action now has to be joined. And then ls again. See, the original file is back. Let's look at the size. It's still 19 megabytes. Fantastic. If you enjoyed the demo so far, I want to encourage you to stick with me, watch the video, and you are going to enjoy more. I will start slowly with some simple input and output operation like how to create a file, how to read a file, how to seek, that means navigating the stream of bytes and all that. Then we are going to write this program as well. So let's get started. The first thing I like to do is to create another folder, which I'm going to put on my desktop. File handling in Go, something like this. This is going to be our project folder. Okay, we are in that project now. Let me do Go mod in it. Right, this looks good. I'm going to open it in my IDE. I use Golang. If you don't have Golang, you can use Visual Studio Code or anything. Now this is my IDE. Let's start with the basics. So I'm going to create a folder here called One Basic. All right, let me zoom this. We are going to be using this part now for the terminal. I'll create a new program here. And the first thing I want to talk about is the idea that a file is nothing but a sequence of bytes, right? Sometimes they call it stream of bytes, especially when it's in motion, when it's being transferred. You say we are transferring streams of bytes. So how does bytes work in Go? Let's look at this. Let me create something called alpha. We have a byte data type, which is actually an alias of uint8. Look at it. So it's nothing to be scared about. So I'm going to create an array. When you hear the word sequence, it sounds like something is in a collection. So it's an array of numbers. So here I'm going to See, let's say 65, 66, 67, 68, 69, and maybe 70. So we have a sequence of bytes here. And what I want to do, I want to write this out into a file. But before I do that, I want to print this out. So I'm going to do a printf character alpha. Let me make sure we have a new line. I'm going to go here and I say go run one basic. As you can see, we have the A, B, C, D, E, F. So that is what we have here. Now, the takeaway here is this. Long time ago, some group of people decide that the number 65 in decimal would map to the letter A in what they call the ASCII table. Everything we do in computing is all about standard. So we have UTF-8, there are different encoding schemes for different languages out there. But the most important thing is that standards allows us to build programs or build systems that are compatible with other systems. So always look out for standard. There is nothing special. This number could have as well be 10, right? And 10 actually means something differently, a whole, right? But they have decided that 65, 66 to 70 would be these alphabets that we are seeing on the screen. So this is what it is. When you want to look at it from the binary perspective, you can convert these numbers to binary, and that is what your computer sees. But this is a sequence of bytes. Now, let's do our first file operation, which is how to write files. So we have data already. Now let's write a file. So I'm going to clean this out. Then let me create a file called F. In Go, when you want to create a file, you use O s.create file. Let's give it, I'm going to put it in the same folder, basic/alpha.txt. Always check for error. If we have an error here, there's no need to continue, so I'm using theta. After that, don't forget to defer the closing of your file. That way you don't have a resource leak. All right, now that we've created the file, we need a way. If you look at the file, for instance, you see it has write. So what can we write? You can write slice of bytes, right? Or you can sequence of bytes is fine. And we already have that here. It also returns the length of the bytes written and possible error. I'm not interested in the length of the byte written, but I'm interested in the error. So I'm going to do this. I also bring some error check here, and that's it. I'm going to go ahead now and run the program. Great. Now let's open the file. As you can see, we have the A, B, C, D to F written to file. Fantastic. Now this is how you write files in Go. Another quick example that I want to show is, let's say you have like a string, right? Most times people have like string. Let's say data. Welcome to a wonderful world. And you want to write this data instead of the bytes. Sure, you can convert that string to bytes by doing this. And you go ahead and run it. Now let's look at the file. You see, we are able to write it. Fantastic. Next, we are going to learn how to read a file. Reading a file in Go is really, really simple. What I'm going to do is to use this same example. So I'm going to come here and I say F2 os.open, right? Let's give it the same file name. Let's do some error checking. Now that we have the file, how do we read it? Well, there are many, many ways to read file. We are going to use the most basic one first, and later we are going to look at how to control what you read. like the size, everything. So I'm going to see BS for byte slice, and then I'm going to see error again. It's going to be io.read all of F2. Let's do some error checking here one more time. And here I'm going to just print out. This returns a slice of bytes. Remember, we're able to convert the string to bytes like this. We can do the opposite here now by doing this. So I'm going to say printf. It's going to be string, and then we pass the bytes. Now we have our string. I'm just going to put a new line here, run it. We should see, welcome to a wonderful world, which was read from this file. Fantastic. This is how you read and write files in Go. Next step, how do you control how much you read? For this, I'm going to create another folder called copier, something like that. And in this folder, let's have a program. I'm going to also create a file here, file.txt. Let's put some random files there. Right, so we have some files there. Let's grab some code from here, like the opening of file. Now we have opened this file. Let me make sure the file path is correct. We're going to point to file.txt. Right, so we have the file open. Of course, we want to do error check. Okay, and defer the closing of the file. Something we probably, let me check something here. See, we forgot to defer the closing of this one, so don't forget it. It's very important. Right, now that we have, when we were reading the file here, in this the last example, we used something called io.readAll. That is reading everything into memory. But imagine this file if it is 10 gig. Reading that much into memory at once would definitely cause you a lot of problems. So Go also provides a way for you to copy data gradually as you wish. So let's do something. I'm going to say io.copy. We have two of them here, copy n and copy is what I want to talk about. If you look at io.copy, it takes a destination where you want to copy to and the source. So we already have the source, so we want to copy from here, right? But where do we copy to? The copy, this is a writer. This writer is just an interface. So, but I know a lot of objects in Go that I've implemented the writer interface, and one of them is os.stdout, which is our terminal. So we are going to copy the data gradually into our terminal. Of course, this returns some data. I'm not interested in anything that it returns. So I'm going to keep it this way. Let me look up, return the bytes written here. Right. So we are going to run this program now. And you see, we have the data here. How about, let's say, instead of copying everything, we're still getting everything. Let's say we are just interested in some path. Sure, you can use copy n and specify how many bytes you want to read. And let's just read 10 bytes out of it. And then I run the code and we have just about what we needed. This is how to control your reading. So if you are receiving payload from the internet and you want to control how much you read, definitely you want to look for copy n. How to seek. Seeking means how do you move between the files. So let me show you an example quickly. Let's bring back the first example. This was the first example, right? Let's say instead of us to, in the copy n, we copied everything from the beginning to n, right? That's how much copy can do. But how about we want to start the copy from here to this place, or we want to even start the copying from here to this place? Basically, a way for us to use like a cursor, it's called seek. You can move in between the bytes and look for the bytes, the portion that you want to use, and extract that, right? So that is what we are going to do next. For this example, I'm going to create another folder as well called seeker, and I will create another small program. I'm basically going to copy everything from here to this place, and I will get a copy of this file here as well. Okay, great. So we are here. Since we are in this folder, just put the folder name here, right? Now, let me give it just the name F. We actually don't need this now. So we have the file open. We have seen how copy work. Let me recreate that copy experience so you can see. We are going to, before we read the file, before we attempt to read from the file, we are going to move the cursor. I'm not interested in any of the return data, but I'm going to say f.seek. We are going to move the cursor to, let's move the cursor like 4 here, 5th step, and then we call io.seek start here. It means whenever we try to read from the file, our read is going to start from here. So it is now time for us to do the reading itself, which basically we can use anything. It doesn't matter at this point. I can just use this one now, this example, and bring the file here. And let's print out the result. As you can see, we have test, name, domain. If you look at the file, we have test, but this is gone because we moved the cursor forward before we started reading. Fantastic. Instead of seek start, you see, we have 3 different ways for the seek. Seek relative to the current offset, seek relative to the end. So do you want to start from the end, or you want to start from the current offset, which basically, for example, if you want to do another seek here, you can use the seek relative to start from where this one stopped. So this is how you use seek to move the cursor in the file, in the stream of the data that you have. Let's do something else with seek. I'm still interested in doing a little bit more, so we are going to write a bigger program. I will start by let me remove everything here, and then let's start a different program, something more interesting. What we are going to do is, let's imagine we have a log file. Let me go to the internet and see example Apache log, something like this. The town doc, I don't know, I'm just looking for some. Okay, nobody's going to leave the Apache log on the internet anyway. Okay, dummy text. Lorraine. Okay. I don't know why we keep getting this thing all the time. So here I'm going to copy everything. And this is what we are going to do. Let's close it. We paste it here. I want us to be able to search for the last occurrence of a particular word. So let's say I put this line. Let me put the word error here. And maybe here I'll put the word HTTP. I want us to write a program that when we search for error, it gives us this line. When we search for HTTP, for instance, it gives us this line. So that's what we are going to work on right now. All right, let's start by declaring some variables here. The keyword we are going to search for now is going to be error. Let's open the file that we want to search, which is this file. We have it already, and we're deferring the closing. It's important. Something that we've not seen. I'm going to create an buff IO reader. New reader. So we are sort of wrapping this file operation in a buffer. This is important because we want to be able to use the buffer to read the line. I could have as well used a different way, but this is how I want to do it. All right, so let's declare more variable here. So let's say last keyword position. Now this one is going to give us where we found the keyword that we're looking for, the last place we found it, and the current position in 64. Okay. Now time to loop. Let's look at the line and error. Now we need the reader, and this is where we are going to read string. Now we are going to read line. Okay, so per line, of course, I always want to check for the error, but before I do that, I'm going to check for that shortly. Before I do that, I want to set current position. I want to increase it in 64. Len the line. Okay. All right. This is where we do the lookup. So if strings contained, all right, let me convert everything to lowercase so that we can do case insensitive match. We are searching in the line. This is to lower and the keyword. Then last keyword position would be current position minus int64. We need to convert this to int64, if else it won't work. Right, now time to check for the error. Of course, if we reach the end of file, we just want to break out of the loop without any issues. If error is not nil, I'm going to return, but this time I want to return with the message called println error reading file. Something like this. All right, after the loop, so this was our loop. Now let's scroll down gently. Let me take everything out here. If we found the thing, right? Let's do something. This is where the seek comes in. File.seek. We name it f, so that's seek. Right? We are starting from there. And of course, io.seek start. We've seen this before. We need to check for error here again. Error seeking file. If everything is good to this level, let's extract the line. You see what we are doing now. After the seek, and then this is the time we're going to have access to now that we've moved the cursor, we now have access to the line that we want. Of course, we need to also check for error, but this time around, not just the error, but we want to make sure it's not an IO error. Error not nil, and error not IO EOF error. Then if that is the case, errors reading file, something like that. If not, we can just print the file here, the lines here. Else, I'm just going to say not found. Not found. Okay, let me close this a little bit and let's look at the program one more time before we run it. We try to find this keyword, whatever keyword that is provided in the file. The last occurrence is what we are looking for here. Basically, what we are doing in the loop is incrementing this number so that we can use it for the seek, right? And immediately we are able to seek, we can do the reading, which is going to give us the line. So that's it. Let's run the code. And you look at it, we have the portion of the file that contains that error. I can make it even more interesting by, it looks like we don't have, the line is not very clear here. So let me make it better. These are lines, different lines. Let me run it. You see, now we have the line that begins with error. How about HTTP that we put there? See, this is the line that begins with HTTP. So seek is very powerful. You can use it to do a whole lot, and I encourage you to take a look at the documentation and learn more. Next is the big one. Okay, welcome to the big one. This program would help us understand a whole lot more about input and output operation in Go. We are going to learn how to chunk a large file into smaller pieces and also assemble the file back to its original state. It's really an interesting program, so sit down, relax, and enjoy. Let me create the folder called filer. I think that was the filer. That was the name I gave it. I'm going to start with a file called splitter here. It's nothing special. It's going to be in the same package, so main. Let's create a function called split file. File path. By the way, if you notice any sort of bug, mistakes, please don't forget to leave a comment for me. Nobody is perfect. We are all learning, and you can share your own experience with me in the comment. So path size will be int64. And basically we can return some errors. All right. The first thing, of course, we need the file, which is the file path. We forgot to type it as a string. Let's check for error. I'm just going to return the error if we have any error. Of course, always remember to defer the closing of your file. Okay, after that, we need some information about the file, like the size of the file. And you can get that from file info. So that is stats. We want to check for error one more time. At this point, we have access to the file like size, name, if it's a directory or anything. We have a lot of access here now. Now, let's define some variables here. Total parts, like how many parts do we want to chunk the file? So we take the file info dot size. and we are going to divide it by, so for example, if our file is, let's say, 1K, and they want to chunk it into 5, then this is what we are going to chunk it, right? The product will be like how many parts it will be. But sometimes you have a remainder, right? Like if the thing doesn't, if the part is not even, then you're going to have a remainder. We need to take care of that as well. So I'm going to say if file info dot size modulus file path, if it's not 0, so that means we have some remainder. I'm just going to increment this to enable us create that extra one. All right. After that, we go into the processing of processing. Sorry about the, let me close that out. So far this is what we've written. We've opened the file. We extracted the file information. From there we can get the size. Then we determine the total parts that we want to chunk the file. In case of a remainder, that means we need to create the extra one. Then we did the increment here. Now in the loop, we need to determine like how many bytes have we processed, how many bytes we haven't. So I will say on processed, let me just say on PS. I'm going to write another function here called mean. Do we have like math.mean? Yeah, but mean int. Do you have mean int 64? Yeah, like this. Okay, I need this to determine the, so part size, file info, something I'm doing that is not right. Oh, I see. Okay, my bad. All right, I'll come back and do something. So let's say mean, I'm going to write a function there. Size, the file info dot size. I'm going to subtract So let me do, I forgot something here. Let's say we're supposed to loop I equal to int 64, right? And then I less than the total parts, I plus plus. That way we are creating the parts, like how many times, right? Then I times the parts. All right, so this is going to give us like how many parts, the bytes that we've not processed. Okay. Now the file that we want to put outside each of the parts, so I'll call it out file, error, os.create. We need to format it a little bit, so I'll use printf here. It's going to start with some name dot path underscore d. So that will be the file path itself. So this is basically the name of the file. And I plus 1 will be like, so you have like path 1, path 2, path 3, like that. Possible formatting directives. So I'm not sure why I have that errors. Print F. Yes. If error is not near, of course, we return the error. If not, I don't want to forget closing of the file, so I'm going to say if error equal to out dot. I want to come here and close the file. If we are unable to close the file, sure thing, we are going to return the error. That is done. Now we need to copy. As you can see, we are going to use our friend copy n. We're going to copy to output file, the file, and the unprocessed bytes, which is UPS. You see, we are using almost everything that we've talked about, and this is the whole idea of writing a full program. So basically, we are done with the processing here in the loop. Let me explain. We need to write this. There's no big deal. So let's write this func. So this is going to take A and B in 64. I think Go definitely would have if A less than B, right, like this. Return A, else return B, and of course in 64. All right, good. So this is let's look at let's finalize it. So we already have the loop. We know we're creating the paths now. I want to do something else here. I'm going to say write metadata, and remove main file. Here I'll return new. I like incremental development. When I do something, I want to test it. My usual way is to do test-driven development, but today we definitely can't do that because the video is going to be too long. And I have a full video on test-driven development, so you can take a look at that. But let's test this let me create a main. All right. I also need, so what do we need? We need to pass the file path, and that's it. And so I need the file in here. Just give me a minute. Let me grab a file and put it in there. So I just copy the file, that same PDF. Right. So let's use that as an example. Let's say split. It's in this folder. You have to put the folder this way because Go start looking at the root. So, and I need to put the file name and the size which I want to split it will be, I'm just going to put something like this. That will be it. So let's run it. If there are no errors, we should see all the paths. You see all the paths are here. It's a lot of them. So we've been able to chunk the file. Now it's time for us to do a little bit more, know how to assemble the file and know how to write the metadata, because we need the metadata to reconstruct it, or else we have to figure it out from the part like the size and everything. Let's work on the metadata. I'm going to call it metadata. This one, we need a way to store just like about some information about the file itself. So I'm going to say metadata struct. The original file name. Sometimes when you're recording a video, it's very difficult to type. Part size, which we already know is in 64. Total parts, it's also in 64. Let's give it some JSON tag. All right, that looks really good. I'm going to say func save metadata. So the file part, of course, that will be a string. Part size and total parts will be in 64. We can return an error. mdata. So metadata, let's construct it here. Original file name will be file path.base. This one, the file path is coming from the Go standard library, so we need the base file name. to extract. So even if they pass like long folder paths, we don't care about the folder paths, we just want the name of the file itself. So that's what we are doing here. Path size is nothing special, we just bring the path size, and then total paths is the same total paths there. All right, this looks fantastic. Let me say MBS is for metadata by slice error JSON. Let's convert it to JSON now. Marshall, and I will pass it this data. We check for error here, and if error is not near, we return the error. Right, I don't want to do much there. This is the time we need to write it out. So metadata file will be file path plus, I'll just say dot metadata dot JSON, something like that. Of course, if error, we're going to write it out now. os.write file. We're going to write this file and the bytes. Already we have the bytes from here. Error is not near. We also need to pass the, so look at the, this is the file mode is important. You can come and look at all the file mode here. It's mostly, I don't know how they do the cross-platform each of it, so you can read that up. 0644 is good. If we have any error, we just return. So this gives us a way to write the metadata. Now that we can write metadata, it's time to go and put the metadata in the split. Open the split file function. So go to splitter.go and go to the split file function. Scroll down here. You see, we left a comment here. So I'm going to say if error equal to, let's set the error, save metadata. We know the file path, right? Path size and the total. We have all the information already. If we have any error, we just return. I'm going to hold off on removing the original file for a minute, but it's time to test it again. So go here, let me increase this 0 with one more 0. Run it. Now look at the metadata. Let's open it and see. Original file, of course, this is good. This was the path size and the total path is 6. So 1, 2, 3, 4, 5, 6. So this is working. Great. Now we know how to split the file, save the metadata. Let's learn how to join it. Let me delete everything here for now. Our program is working, so I'm not even afraid of removing the original file anymore. So I will ignore the return error and I say os.remove file path. Okay, that is going to remove the original file. Let's create a join func, join files. To join the file, we only need the file path because we are going to use the metadata. So here, we need the metadata in order to join the file, but we currently, if you look at the metadata, we can only save. We need a way to load. So let me go back here and just code that. Let's just code along. We're going to say mdata, which is for metadata. Let's say load metadata. Sometimes you want to, this, like if you are doing test-driven development, you are going to write the code first anyway. So If error is not new, return error. After this, what else? The out file will be error os.create. So it's the same thing. Remember, we need let me open metadata. We are going to use this original name. We're going to put out just the original name, right? If we have any error, we want to return the error to the caller. After that, we defer the closing of out file. Very important, don't forget it. Okay, now time to do the copying. So for I equals, don't forget, we need to convert it to int64. If not, it won't work. Right, I less than, the metadata knows the size. This, what do you call it? The total parts that we have. So let's go back to splint, right? And then I++. We're basically doing the opposite of what we've done. So part file name, may capitalize the name. Remember how we saved it here? Let me open it. This was it, something like this, right? But this time around is going to be the file path underscore this. So it's going to be I+1. Yeah, it looks good. I think this looks good. This was the same name that we used to save it. The file path dot path underscore the number. So that looks good. Path file. So we need to open the file now. os.open. You have seen this before. Right, if we encounter any error, we can return. We also need to close it here. So I'm going to copy the closing logic. We need to close. Now, something really important here. Whenever you are processing any file in a loop, you want to close the file in that loop. Make sure the file is closed in the loop, else you are going to have some resource leak. All right. So we are not going to forget our closing. And then, of course, we just do the usual copy, io.copy. We're copying to out file. And then the path files where we're copying from. So all the paths, we are basically just copying them back. And we check for error. After if everything is successful, we're going to os.remove. We're going to remove this. And this is why I saved it in, because I was going to reuse it. I saved it in this variable and I didn't pass it directly here. When we are done, so basically we are sort of done with the loop part. But I also want to come here and remove the metadata. So just to clean up everything. So file path dot. I don't want to make mistake with the metadata. So let's go and get the name properly. Yeah, something like this. This was the name. So let's go back to Splinter. And then here. So we delete the metadata and then we return name. So here something is still missing here. We need to go and write this function. So let's go and write it. Open metadata. Create a function. File path. We need to return metadata or an error. we also need the sort of the name of the metadata we want to load. The metadata byte slice os.read file. We're going to read this file. Let me copy the error check down here. Because we are returning two different values now, we need to add nil. But in case, let's assume that, let me declare something here called file error not found or something like this, right? No problems, I think it's okay. But here, what I wanted to show you is this. It's possible for, you can check if os dot is not exist, error, that means the file does not exist. You know, file not found. But sometimes you want to return like custom error so that your caller can, you know, check for that specific error, in case you want to do that. Here, mdata will be metadata. Now we have the byte slice. We need to turn it from that byte slice to the real object. So we've read in the JSON, we need to turn it to the object. So basically like mapping it. JSON.unmarshal. We are doing the opposite of what we did. We want to unmarshal this into this one. If error is not near, then we just return near an error. All right, else we are going to return reference to this and error will be near. Let's go back to the splitter and make sure everything looks good. I don't see any errors. So let's go to main and test it. This time around, I'm going to run this one, run the splitting first. So we have this, it works. We can split now. I'm going to run the join, passing it the, just remember we can do this like this. I'm not checking for the error yet, so I think like we should do that. Log.theta. All right, and then run it. So it worked, but the file is here. It's not in this folder, so that's the problem. Yeah, so it's no problem. So if we want, here, the reason why we don't have the file in this folder is because when we're saving the meta, so let me go back here. When we're saving the metadata, this is it here now. No, we need to put this one back here. When we're saving the, when we're saving the metadata, we only save the name here, right? So we're always going to have it at the root or at the root document, so it's okay. So, but the most important thing is that the code works. All right, that was it. If you want to add these command line features that we had here, for example, action, let's look at here, all right? Action equals, let's say split, file equals this, and size, that means split by 5. If you want to have that command line argument, you can use the flag package to do it. If you enjoyed the video, kindly subscribe to the channel. I have a whole lot more. Please, if you need anything, kindly leave a comment and I will try my best to record. Thank you. Bye for now.